Hi, this is Brian Atkins. I'm a member of the Storage Grid Web Scale team here at NetApp. Today we'll be using our example Ansible rule and playbook to prepare several Red Hat Enterprise Linux hosts and install Storage Grid Web Scale 10.4. To get the most out of this video, you should check out the Storage Grid Web Scale installation guide for Red Hat Enterprise Linux deployments, especially the storage recommendations and configuring the host network sections. The installation package for Storage Grid WebScale and RPM-based systems comes as a compressed tar file. It contains installation RPMs and, down under the extras directory, the Ansible rule. I have already created an Ansible working directory with the Storage Grid rule and copied the example playbook file here. I have also created an inventory file with my 4 RHEL hosts and provided an Ansible config file that points to that inventory file. Now let's take a look at the playbook. Comments in the playbook describe how to use it and the storage grid rule. Together, they provide all the necessary preparation for the RHEL host, as well as the installation and startup of storage grid itself. All tasks in this playbook and the storage grid rule are conditional on appropriate variables being set. Just omit the variables for tasks you don't need and they'll be skipped. In fact, if you run the playbook with no variables set, it will do nothing. This allows you to configure only those parts of the playbook and rule that you need. At the top of the playbook is a check on Ansible version. We found a problem in version 2.2 that was resolved in 2.2.1. Feel free to try other versions if you can't use 2.2.1, but be aware that this could result in some manual cleanup on the target hosts. Next comes a pre-task for setting up networks that might be necessary for accessing resources needed by the host. In our case, we'll use it to configure an interface to access shared storage. Shared storage for storage grid nodes allows us to cold migrate them off the host for host maintenance, so it's a significant advantage. You can use direct attached storage, but if you do, we recommend running only one storage grid node per host. The first item in the rule is prerequisite package installation. If you already have all the packages you need, you can skip specifying packages here. We'll use this to install Docker and some iSCSI packages for our shared storage. We recommend installing Docker from RHEL Extras channel, so make sure that that channel is enabled on the target hosts. Next comes node networking setup. The installation guide provides example node network configurations, including one-to-one interface mapping and a more complex example using LACP bonding and VLANs. If you use one-to-one mapping, you can skip this step. Today, we'll be configuring a bond with multiple VLANs. For production use, Docker should be configured to use the device mapper storage driver in direct LVM mode. The next section allows you to specify the LVM volume group, logical volume name, and block devices to use for physical volumes. If you are using an existing volume group, configure the volume group name, but omit the list of devices to use for physical volumes. You can omit the volume group name to skip direct LVM configuration altogether. Also, this task will check that direct LVM hasn't already been configured by other means, such as the Docker Storage Setup service. If direct LVM has been configured, these tasks will be skipped even if you specify values here. Note that it is not necessary and isn't recommended to use shared storage for the Docker container pool. Next comes iSCSI configuration for shared storage. We'll use this to provide luns to our storage grid node containers. From here you can set the iSCSI initiator name and specify target portals to log into. I have already configured the appropriate host and LUN mappings on the storage array. Next comes the storage grid RPM installation. We provide two methods, path and repo. If you have a local RPM repository, you can copy the storage grid WebScale RPMs and repo data from the installation package to the repository and install from there. Otherwise, you can specify a path to the RPMs and the role will copy them over before installing them locally, which is what we'll do. The final step is to copy individual storage grid WebScale node configuration files to the hosts and start up the storage grid service. For more information on creating the configuration files, check out the installation guide. We won't be addressing that in this video. Now let's take a look at the variable settings we'll be using. Since all 4 hosts have been configured the same way, we can put most of our variables in a group vars file. Here we specify the list of prerequisite packages we'll need, the networking configuration, which includes a bond, in this case an active backup instead of LACP, the mapping of slaves to the bond, and the VLANs to create on the bond. Note, bond isn't required. You could use VLAN configuration directly on physical devices. Next, we specify the volume group to use for the device mapper storage driver. We'll let the logical volume name use the default value provided by the role, so we aren't specifying it here. Next comes the iSCSI setup for accessing the shared storage, and finally, the storage grid package installation settings. Next, we'll take a look at the host vars files. The only items we have here are the shared storage interfaces, which require unique IP addresses, and a list of node configuration file paths to deploy to the host. Each host must have a unique set of nodes, or you'll end up with duplicate nodes in the grid. I've put the node configuration files in the node configs directory and specified the paths here. The first host will be running our primary admin and API gateway nodes. The other hosts are each running single storage nodes. Here's an example. Okay, with the group and host vars files and node config files filled out, we are ready to run the playbook. Note that I haven't edited the playbook itself at all. Everything is set using group and host var files. Let's run it using check mode first to make sure we don't have any problems with our variable settings. Okay, that error is when we tried to start the Docker daemon. Since we ran in check mode, Docker wasn't really installed, so this error kind of makes sense. Now let's run it for real. Full disclosure, some of these steps take some time, especially copying the RPMs to the target hosts, installing the RPMs, and node startup, which involves importing node images into Docker. I've edited this video to reduce the wait times for these tasks. Okay, that's it. It looks like everything completed. The hosts should be, or the nodes should be starting up on the hosts. Let's see how that's going. Okay, we can see that each of the nodes is reporting a status that it's currently uploading configuration files. So what that's doing is actually importing the vmdk into Docker in order to be able to create the container and start up the service. So everything seems to be running smoothly. That's it for this video. Thank you very much for watching.